Gas under pressure. Pressure is the amount of force exerted on a given area. You can think of this as the number of collisions of particles against the inside of the container. Compare the basketball with the beach ball in Figure 9. The balls have the same volume and contain particles of gas, air, that constantly collide with one another and with the inside surface of the balls. Notice, however, that there are more particles in the basketball than in the beach ball. As a result, more particles collide with the inside surface of the basketball than with the inside surface of the beach ball. When the number of collisions increases, the force on the inside surface of the ball increases. This increased force leads to increased pressure. Figure 9. Both balls shown here are full of air, but the pressure in the basketball is higher than the pressure in the beach ball. This basketball has higher pressure than the beach ball because the greater number of particles of gas are closer together. Therefore, they collide with the inside of the ball at a faster rate. The beach ball has a lower pressure than the basketball because the lesser number of particles of gas are farther apart. Therefore, they collide with the inside of the ball at a slower rate. Review. 1. List 2 properties that all particles of matter have in common. 2. Describe solids, liquids, and gases in terms of shape and volume. 3. Why can the volume of a gas change? 4. Applying concepts. Explain what happens inside the ball when you pump up a flat basketball. Laws describe gas behavior. Earlier in this chapter, you learned about the atoms and molecules in both solids and liquids. You learned that compared with gas particles, the particles of solids and liquids are closely packed together. As a result, solids and liquids do not change volume very much. Gases, on the other hand, behave differently. Their volume can change by a large amount. It's easy to measure the volume of a solid or liquid, but how do you measure the volume of a gas? Isn't the volume of a gas the same as the volume of its container? The answer is yes, but there are other factors such as pressure to consider. Boyle's Law. Imagine a diver at a depth of 10 meters blowing a bubble of air. As the bubble rises, its volume increases. By the time the bubble reaches the surface, its original volume will have doubled due to the decrease in pressure. The relationship between the volume and pressure of a gas is known as Boyle's Law because it was first discovered by Robert Boyle, a 17th century Irish chemist. Boyle's Law states that for a fixed amount of gas at a constant temperature, the volume of the gas increases as its pressure decreases. Likewise, the volume of a gas decreases as its pressure increases. Boyle's Law is illustrated by the model in Figure 10. Figure 10 Boyle's Law. Each illustration shows the same piston and the same amount of gas at the same temperature. Lifting the plunger decreases the pressure of the gas. The particles of gas spread farther apart. The volume of the gas increases as the pressure decreases. Releasing the plunger allows the gas to change to an intermediate volume and pressure. Pushing the plunger increases the pressure of the gas. The particles of gas are forced closer together. The volume of the gas decreases as the pressure increases. Weather balloons demonstrate a practical use of Boyle's Law. A weather balloon carries equipment into the atmosphere to collect information used to predict the weather. This balloon is filled with only a small amount of gas because the pressure of the gas decreases and the volume increases as the balloon rises. If the balloon were filled with too much gas, it would pop as the volume of the gas increased. Charles' Law. An inflated balloon will also pop when it gets too hot, demonstrating another gas law, Charles' law. Charles' law states that for a fixed amount of gas at a constant pressure, the volume of the gas increases as its temperature increases. Likewise, the volume of the gas decreases as its temperature decreases. Charles' law is illustrated by the model in Figure 11. You can see Charles' law in action by putting an inflated balloon in the freezer. Wait about 10 minutes and see what happens. Figure 11, Charles' law. Each illustration shows the same piston and the same amount of gas at the same pressure. Lowering the temperature of the gas causes the particles to move more slowly. They hit the sides of the piston less often and with less force. As a result, the volume of the gas decreases. Raising the temperature of the gas causes the particles to move more quickly. They hit the sides of the piston more often and with greater force. As a result, the volume of the gas increases. It's your turn to practice what you've learned. You will start with using vocabulary. For each pair of terms, explain the difference in meaning. You will be doing numbers 1 through 4. Then, you will be doing understanding concepts. Numbers 5 through 16. For numbers 5 through 13, you may write A, B, C, or D as your answer. For numbers 14, 15, and 16, please write a complete sentence. You do not need to respond to question 17. We'll be going to critical thinking and problem solving. Here there are 4 questions. You will only need to select one of these to respond to. Please tell us which one you are answering, 18, 19, 20, or 21. The next section is math and science. We will only be doing question 23. It has 3 parts, so please be sure to respond to all 3 of those questions. You will be using this graph.